Did you do yesterday's homework?
No.
Oh, good.
So I got it on the thing.
Perfect. Then it might be a perfect opportunity for you to get some
Are
help.
You're going to do it on the board?
I'm going to do it on the board.
Okay.
I'm not even going to do it so it's mirror imaged. See. Let me just find my... Is there a towel around here? Perfect. All right.
There's like a random like syringe thing on the floor. It's like plastic.
Oh, a baby syringe. We use those all the time. It's not my drug addict's syringe, I promise. Alright, so we're looking at this homework, and you guys are all freaking out about it, and why don't I take a look? Can you see my computer?
Okay, I'm going to go.
Here. You don't need to see my computer. Can I see your computer? That's what I meant to say.
Yeah, okay.
Alright. This is a really good problem, and the reason why this is a really good problem is because it actually brings in the idea of calculus. And you guys are thinking, oh, man, why am I doing calculus, especially in a standardized test? Well, hey, don't look at me, man. This is kind of a problem that they gave you on the EOC, which is the end of course exam. And since it falls under the categories of standardized tests, I figured I'd throw it out there and see how you guys fare on this thing. All right? So let's start the problem all together. All right, let's see. You want to make a box for an art project and only one piece of cardboard. You only have one piece of cardboard. Its length is 12 inches by 8 inches. All right, so you've got a piece of cardboard, 12 by 8. Cool? And then what you're doing is you cut a square into each side. A length x. X by x. It's a square that's x by x. Can you guys see that? Okay, wait. I turned off the camera because I wanted to go higher quality. All right. So it's x by x. And do you guys see that after I cut out those squares, I can fold maybe along this dotted line like this to make a box? Do you see that? It's going to be some kind of box like this. Yeah? Yes? No? I don't know?
Yes.
Okay, good. All right, let's see. What's the volume of this box? That's what I'm curious to know. All right, the height of the box, how tall is the box? X, perfect.
Oh.
All right, what is this length down here?
8.
Nope,
Oh.
it's 8
8.
minus 2x. Because this length right here is actually this length right here. Right? And the whole thing from here to here was 8, so from here to here is 8 minus 2x. Yeah, exactly. You guys got it? All right. And then what is the depth of this box?
12 minus 2x.
Perfect. So if I want the volume, it would be length times width times height. Right? So 8 minus 2x times 12 minus 2x, 12 minus 2x times x. Are you listening to Shoop?
I don't know if they heard you.
They're listening to like old 90s rap music. Anyway. Shoop, shoop, be-doo, shoop, be-doo, be-doo. What's up, Sophia? Alright. Jenna, how are we? Did you get this equation?
Yeah, I watched it twice.
What up, dude? What did you want to see me for?
Actually, I just wanted to come up here to hang out.
Oh yeah, come and hang out. Yeah.
Because I hate being in that office.
Yeah, I can see why. Yeah, all right, fine. We got to FOIL this out. All right, let's see. I'm going to pull out a 2 out of this thing right here. Well, let's see. I'm just going to FOIL it. Like, you know, there's nothing wrong with foiling it, right? All right, yeah. Oh, Jen already FOILed it. All right, good, awesome. 4 x squared minus 40x plus 96. That's, you foiled this part, right? That's what you did? Okay, all right. And then we need to
Add the x.
we need not add the x, but we need to distribute this x to everything. So this is actually 4x cubed
Minus 40
minus 40x squared
plus
plus 96x.
x.
Are we cool? Yeah. So you're just throwing an x in there. All right. I was confused on whether or not simplifying this, setting it equal to 0 and dividing by 4. Why would you set equal to 0 and divide by 4? I don't understand. Oh, it just makes it easier to look at. All right. Okay. No, but let's see. What are some things that so we're saying that the volume as a function of x is equal to this. Are we cool? Let's do some, well, I'll tell you what, let's graph it. How's that? Can you graph that on Desmos? Yeah, did you? Okay, let me look at Desmos right here. Desmos, because we were just talking about how awesome math is, me and Alice. She hates math. Alright, so let's see. This would be 4x cubed minus 40x squared plus 96x. Awesome. So I got some freaky looking big old cubic sign. Are we cool? And it looks kind of like this. I'm out of space here. I'm going to write it over here. Alright. It's a big old cubic sign, and it goes like this. It goes all the way up here, and it comes down and comes back up like that. Cubic function. And let's see, where are some of the turning points? 4 and 6. So this is 4 over here, and this is 6 over here. Are we cool with that? Yeah? You guys like that? All right. Let's talk about this thing. This is saying that the volume as a function of x. Hey, dudes, could you turn it down a little bit? I'm sorry. I'm like trying to do math and then I start singing along and it's throwing me off.
Sorry, Mr. Dolly.
No, it's cool. I'm just tutoring right now and I'm like shoot bedu. What? Oh no, it gets deathly hot in here. So sorry. All right. No, that's perfect. That's perfect. It's not as distracting. So let's check this out. All right. You've got your volume as a function of x. If x were 0, what would volume be? 0. Does that make sense to you? Yeah, exactly, because there's no height. It's like I'm making a cardboard box, or I'm making a box out of this sheet of paper, but I'm not going to cut the corners, right? You need to cut the corners to fold it up to make the box and whatever, but you're not going to cut the corners. Deal with it. What's the volume of the box? There's no volume of the box. It's a sheet of paper. Does that make sense? What about if x equals 4? What is the volume? It's equal to 0.
I'll make it sound like she's in trouble.
Why?
I said I'll make it sound like she's in trouble.
Why is that?
No, I don't. I want to scare her.
Oh, you want to start? Okay.
Yeah. Because if x were equal to 4, then this thing is only 8 inches long. If I cut off a 4-inch square over here and a 4-inch square over here, I'd basically be left with a piece of paper that is 4 inches by 8 inches, and I can't make a box out of it. Does that make sense? So again, you'd have a piece of paper that no box, tough, deal with it. So this graph actually makes perfect sense to me. I hope it makes sense to you. And what we can do, and this is why it comes to calculus. This is where it comes to calculus. Say that you want to, say that you actually own a company that makes boxes for some kind of design. Say that you own a company that wants to make some kind of box. And so what you want to do is you want to choose what X value you cut off in order to give you the most amount of volume possible. Say that maybe instead of boxes, you're making fish tanks, right? And you want to make the fish tank that holds the most amount of water. What X do you choose? Obviously, you wouldn't choose 4. Nor would you choose 0. Looking at decimals, it says that X equals 1.569. Absolutely. That's, if X equals 1.569, it gives you your peak value. Now, I think over here, this is what the math says, but we can kind of disregard this because it doesn't really make sense physically. Once you go beyond 4, it's like, how are you going to cut off a 5-inch square over here and a 5-inch square over there? You know what I mean? You can't have negative value. So we're disregarding cutting off anything big, a square bigger than 4. But apparently, if you cut off a square that is 1.569, that gives you your peak value. Now, in algebra 2, you don't know the math of calculus. So what you need to do is you need to look at a graph and try to determine what these values are. And by the way, in order to get 1.569, you look at decimals and you say, well, it's about 1.569, and then you can plug that number into here, and then you would end up getting 67.604. Or you look at decimals again, and it will tell you the answer twice. Does that make sense? So let's see, what other question is it asking? Oh, okay, all right, here's another thing. In Algebra 2, you don't have the calculus tools that you need in order to find this number without using a graphing calculator. In calculus, what we would do is we would do something where we would take the derivative of this thing, and then we would be able to set that equal to 0 and then figure out what this number is. That's what Isaac Newton did when he invented calculus before graphing calculators. Right? Isaac Newton was to be like, well, you need a graphing calculator in order to solve that. I can't solve that problem. 1.569 is wrong for question 9. All right, I'll tell you what. Then the assignment is dumb. That's my answer to that. Hold on one second. I still never looked it up, what that is.
What? Mr. Golden, if someone born in the late 90s knows what it means, you need to know what it means.
From what I understand, I don't think it would be good for me to know what it means. I'd just stop using it. But it was a great reference when I was using it.
What were you using it in relation to?
In trigonometry,
Oh.
they have the side adjacent opposite, and I was like,
Yeah.
Instead of calling it O because that looks like a 0, I'm going to call it OPP as an opposite. You got it?
No, that's actually really good.
Right. Like,
I mean, I guess you can still use that. Just don't mention rap.
okay.
Because then it can get a little inappropriate.
Well, all right. I'll tell you what, Jenna. Well, Sophia, let me take a look at. Oh no, they're talking to me about old '90s rap. Let me take a look at the answers. And check this out. I'm looking at the answers while this thing is on a video recording. So you guys can't see my computer screen, but when I upload this to a YouTube video and then send it out to everybody, there's the answers, everybody. All right, let's take a look. Okay, let's see. Huh. All right, let's see. What is the length, the width? Where did I get these numbers? All right, let's see. Use Vx to determine the graph of the greatest volume. What is the greatest volume it can have? Okay, so the greatest volume is 67.603, right? Yeah, and then for the length I did 12 minus 2 times blah blah blah. What is 12 minus 2 times 1.56? Let's look that up.
Is this for question 9?
Minus 2 times 1.5. 12 minus 2 times 1.59. 8 point. Oh, that's what I got. Yeah. So the length is that I put down was 8.861. And the width that I put down was 4.861. And the height is not 3.139. I don't know why I have that. It's 1.569, right? 1.569. So it's the height that got messed up. Is that what you guys are saying? The length and width were correct, but the height was all screwed up.
But what did we plug
Okay.
in for x?
It would be 1.569 for x, which is your height. Were the rest of the questions correct?
How about like question?
Oh, wait. The interval one wasn't correct, right? It doesn't go from 0 to 8. It goes from 0 to 4. Is that what you said? The domain one? It goes from 0 to 4. I accidentally put 0 to 8. All right, were the rest of them correct? All right. Good. That is a really good problem. I don't regret giving it to you. Because you would have to know. I mean, is it testing you on Algebra 2 things? Absolutely. This right here is a cubic function. You guys should know about cubic functions. You guys should be able to plug it into a graph. And from that, you should be able to take a look at where does it go to the top. Now, I would hope that on the test, if they give this to you on a test, I hope that on the test, if they give this to you on a test, they would give you a graphic calculator in order to do that. I'm expecting them not so that you don't need to know calculus, but this is a good problem. All right, what do I mean by subject to constraint? Let me see. Oh, okay. What I mean by subject to constraint is that the length of the box that would give you a perfect square centimeter or 60 or thing. Yeah, you could just plug in y equals 64 and figure out what the answer is, right? Yeah, exactly. That's exactly what you would do. You would find what does the corresponding x value is for the y value of 64. And what I mean by subject to constraint is that, like, you can't have your x value be like 40 or you know, like, it has to make sense. Obviously, it's between 0 and 4. If your x value was outside of that, then it wouldn't be subject to the constraint. Does that make sense? So 0 to 4 is the range of our box, right? Is the range of our x that we're allowed to cut off. And so that sets up the constraint of your problem. It sets up that, like, so any answer you get that's beyond 0 and 4 doesn't make any sense. And apparently there's 2 spots that give you 67 or 64 centimeters. No, well, yes, you're right. There's 3 of them. Here, here, and here. You could choose any of these x values, but this one right here is outside of our constraint. Right? Yeah, choosing 8 would be the best option, absolutely. But I also said that you can choose 9.6568. And both of those would give you a correct answer. Either of those would give you a correct answer. So you need to understand the math that you're doing before you do it. Yours shows 2. What do you mean 2? What do you mean 2, Jenna? Oh. The corresponding x value is 2? Oh, yeah. The corresponding x value is 2. Yeah, you're right. So what is the length? The corresponding x value is 2, so then I ask, what is the length of the box? We're talking about, like, the second to last question, right? Yeah. So it's 8. That's your answer. And if I ask for the width, then the width would be 4, I think. Does that make sense? It's not the second to last question. It's like the 5th to last question. All right. Was that something that I've taught you before? Did that have anything to do with chapter 16, math traps? No. It didn't. And it was probably horribly placed. But was it a good problem for you to do? Absolutely. Absolutely. And here's the reason why. Is because, yes, you're taking ACT test in February, right? Or not in February, in March. You're taking the ACT test in March. But you're also going to be taking this test called the EOC in May. And that's the end of course exam for Algebra 2. And there's going to be one problem on the EOC that looks like this. Last year's problem was tougher. Last year's problem asked you to find the volume of a coffee cup. And then using the equation for the volume of a coffee cup, if the coffee cup were filled with paint and it spilled all over the floor, how much surface area would it take up? The volume of a coffee cup, that equation can be really crazy, because you know the volume of a cylinder, you also know the volume of a circle or of a sphere, but the volume of a coffee cup, that's called the volume of a truncated cylinder, because it's actually a cylinder that gets smaller on the bottom.
Oh, like a mug? Or no.
Like a coffee cup.
Oh yeah.
Like the red cup that you find at parties.
Oh, like this. I forget what they're called.
Like a regular cup. A cup is bigger on top than it is on the bottom. It's a cylinder, but it's not a perfect cylinder.
Oh.
So the equation is much more complicated. And I don't think they ask you to derive that equation. I can't derive that equation off the top of my head. Actually, I can. But I don't know it off the top of my head. I would have to calculate it. But what I'm saying is, and to do that, I would actually need calculus. But like, I think what they did was they gave you that equation. This is later on. So I'm just saying, there's going to be problems that you're going to be faced with on standardized tests that look just like this. And I probably should have relabeled this thing not chapter 16 trap thing. I should probably relabel it as EOC practice problem number 1 or something like that. Yeah, absolutely. I'm going to be giving you guys EOC practice as well. I want you to do well on these tests. It only benefits you. So I want you to do well on the EOC. I want you to do well on the SAT, on the ACT, and the ASVB, or ASVAB. Is the EOC a part of your grade? Technically, I'm supposed to make it a part of your grade. So I think I will need to. But I'm not sure. I have to double check on that. I think they might have changed the rules. But even if they did change the rules, to be honest with you, I kind of want to make it a part of your grade. Think about this. You guys have been getting freebie passes on all of your homeworks and all of your tests that you've taken, as far as having unlimited time limit and all that kind of stuff, unlimited tries, or at least 4 tries. This would be the only one I'm asking you to do that's like hardcore. And the EOC, I don't even think you have a time limit. Yeah, the EOC doesn't have a time limit. There's no time limit. Oh. Well, hopefully you've gotten some muscles, at least some math muscles, after you've done so many of my SAT tests. All right. Any other questions? Because I know Lucas was freaking out about it. I know Bradley hated this particular problem. What about the next quizzer? What's the next quizzer? Oh, there's a train leaving the station problem? Man, I did not give you the right... I called these the wrong thing. All right, let me take a look. Are you talking about Math Traps Part 3? train is traveling along a straight and level track directly west and east in such a manner that its position is okay. Should be describe the position of the train at noon. Oh. Wait. Oh. Dude. Oh, wait. I plugged in the wrong answer. All right. The answer is negative 120 for today's quizzer. No, it's negative 120. You're right. You would plug in t equals 0. Oh, you're right. You're right. Oh, gosh, you're so smart. I'll tell you what. I'll give them credit for both those answers. But you are absolutely right. I forgot. I didn't specify a direction. I just specified a distance. Yeah. For some reason, I put 0 in. Anyway, that problem was super easy. I think that there were like other parts to that problem. I just got too lazy and didn't give them to you.
You never said bad.
All right. So wait a second. Before we go, Sophia, was there some stuff that you wanted me to fix in the grade book? All right. Let me stop the recording, and then we'll go take a look at the grade book.